Hello everyone and welcome to the launch webinar of GigaSpaces Extreme Application Platform ZAP 7.0. Today we'll hear from GigaSpaces CTO Nati Shalom, the vision and the highlights of ZAP 7.0. We will later hear from Kees de Groot, the lead architect at eBay Marktplaats NL, about his experiences with GigaSpaces ZAP. Please feel free to send your questions during the webinar using the chat tool. We will respond to your questions during the webinar as well as at the end during the Q&A session. I wish you an enjoyable and interesting webinar, and I urge you to fill in our survey at the end of the webinar. Your inputs are extremely valuable to us. So with no further ado, I'll pass on the mic to Nati Shalom, GigaSpaces CTO.
Thank you, Alit, and thank you, Kees, for joining me to this session. I think it's a fairly exciting moment to be at the point where a release is out and we have a very interesting case study to look for during this session. I'll basically start with talking about the GigaSpaces vision and kind of introducing GigaSpaces to those who are not familiar with that. Then I'll go to some of the highlights behind GigaSpaces 7.0 and how that fits into that vision and the roadmap of our product. At the end of the day, we'll also summarize after a case. We'll provide a very interesting case study about how we implemented GigaSpaces in one of the most popular e-commerce sites in the Netherlands, and we'll conclude at the end. So a few words about GigaSpaces. GigaSpaces is really about to make Suite applications simple and to enable users to write the application on the distributed cluster as if it was one single machine. That in itself means that we're trying to solve two main things. One is take advantage of distributed computing, which is a fairly new model, I think, in the market in the application architecture space. And the second thing is to make it simple enough so that users that already know how to build client-server application will be able to jump into that model very easily. As you can see from the list of customers and the list of references, the early adopters of that technology has been mostly in the financial industry and telco industry, but we're starting to see the adoption of that model on the more mainstream application, the e-commerce, the online gaming, and all those type of applications. We'll see in a second one of the reasons why. Talking about the vision, I've taken a snapshot from a presentation of Forrester research done recently. And basically what we can see here is a way in which the IT should be running. What we can see at the top is a list of applications, and at the bottom, the actual hardware resource that needs to serve the application. Today, we usually run the application on the dedicated resources, which basically means that they're running in a silo, and if they're not utilizing the resources are still coupled with the application, and no one else can take advantage of those idle resources. In this picture, and that shows the ideal world, what we really want to get into is that the application would consume resources in an on-demand basis out of a pool of available resources, and we'll release them when they don't need to. We also want to attach the cost based on utilization. So we want to use the resources as we need and pay only for what we use, which is quite different than the way most applications are running today. Speaking of which, if we really look at the applications, what we'll find is that if we'll take any existing application organization and we look at the way the IT is being architected, one problem has been solved to get to that ideal model. We can start machine through virtual machines or whatever very easily. However, even if we can start a new machine easily through a call of an API, it is very likely that most of the application wouldn't really know that it exists. And even if they would know, they probably wouldn't know what to do with it. They would not be able to take advantage of the fact that we have more resources available to pull them into the application when there is a load, for example. They will not be even able to use it if there is a failover situation. Usually that level of activity or that level of behavior involves either changing a configuration or code or some sort of a manual work. The demand, therefore, from the application and therefore the middleware that supports that application is to be built for that type of dynamic environment. And basically that means that the middleware that was designed or that needs to be designed for that world needs to deliver the fault-tolerant and self-healing in a transparent way, and as well as providing linear scalability that will enable the application to really run across this pooled machine only when they need to and free those resources when they don't need to. Performance is an important factor, not just to get to our numbers and our throughput requirements, but to enable us to really leverage the hardware in the most efficient way, meaning that we'll need to take advantage of the actual CPU power that we have at our hand. The problem, as most of us already know, is that most of the existing middleware were not designed to that world, and therefore, not surprisingly, do not really addresses all those requirements. In GigaSpaces, we came up with a model a few years ago, which is called space-based architecture, which we refer to as the secret sauce behind everything that we do in our product. Space-based architecture is not really a new model. It was a model that was developed back in the late 80s, and it's a concept that is called tuple space. It basically provides a shared address space that enables distributed application to share state and coordinate actions. That in itself enabled to take those distributed applications and glue them together so that they can behave to an end user as if they were running on a single machine. So that's one core aspect that we leverage from that model. In addition to that, we designed this space model so that it will enable us to run application in a linear scalable manner. And to get to that point, we combined, along with that space, other patterns that were learned through the years of experience with working with the most demanding application in the world, and architected those patterns alongside the space model into something that is called space-based architecture, which is a blueprint or broader approach to building scalable application, and that includes partitioning, that includes how we package the application and how we build that so that adding another machine and any other resource will enable us to increase the number of users or throughput linearly with a direct proportion to the number of machines that we're adding to our system. One of the main goals that we had with GigaSpaces and 7.0 is actually the first milestone to that is what we call the end solution to scalability. One of the common, I would say, thing that I use to describe scalability is that you're always as strong as the weakest link. And the top level here really shows a typical flow of a transaction of a typical web application and what really happens behind the scenes when a user clicks a button on a web page. That usually goes to a web server or to a load balancer. That load balancer routes that to the web server. That goes to the application server. Each one of them needs to maintain its own high availability, which means that there is a redundant call here to its backup. And in some cases, there is also messaging involved. And there is also a call to the database and another redundant call to the backup of that database. All that during a transaction flow when a single user hit a button. So what we can see is that there are several problems here, or challenges, I would say. One is the number of moving parts. There are too many moving parts. Each one of them assumes nothing about the other tier and therefore built its own clustering model, high availability model, etc. The other thing that we can see in that picture is that we have a lot of network hops, which basically means that when a user clicks a button, if he needs to go to all those hops, the latency is going to be driven by the number of calls that we're going to have between those different tiers, which means that we're going to be limited in how fast we can do. Even if we'll speed up the database, we're still going to be limited by the speed by the application server, all the tiers before the database, etc. And this is where the space-based architecture comes, I think, in its most efficient way. What we're doing with the ZAP architecture, which is based on the space model, is essentially taking the first challenge, which is the number of moving parts, and reducing the number of moving parts of application by creating a single cluster for the entire middleware. And that brings the application platform that can run on that single cluster, and therefore we reduce a lot of the moving parts. The other thing that we're doing is we're putting or we're assembling the application into unit of work that has from an end user perspective, fulfill all the requests of that end user within a single unit. So there is no need for a distributed and redundant network call to serve a single user request. And by partitioning those requests, each request can go to a different server, but all of them are basically resolved and handled within a single server, and therefore we reduce a lot of the chattiness in the previous architecture. Obviously, because we have less moving parts, we also reduce the number of network calls. And as you can see here, we can reduce the number of network calls quite effectively. The fact that most of the interaction of our application happens also locally means that we can even deal with complex workflow in that way without hitting the actual user. The interaction with the database is also pushed to the background, which basically means that if we're looking at that from an architecture perspective, the user is not going to be blocked on database operations. So we're dealing with application containers that enable us to deal with scalability of the application layer. The memory data grid enable us to buffer the database and basically deal with database calls at the asynchronous manner. We added session high availability and dynamic scalability at the web layer to enable us to really add more web containers on demand and communicate that back to the load balancer that will immediately detect when a new web server comes and joins, and while ensuring that the user session is not going to fall or going to break, and that's where the session high availability comes into place. So that, when we say an end-to-end solution, that's really what it means. An end-to-end scalability solution in one place from the web to the database, and it's not just the caching solution that solves the database bottleneck, it really enables you to solve all the tiers in that type of environment. Talking about an end-to-end solution, if we look at all the hero story, I'm not sure if some of you are following the highscalability.com, for example, where I have all these stories about how Twitter solved the scalability problem, how Dig solved the scalability problem. We've also seen that in many of our customers. You'll see that a lot of them looked at scalability as an afterthought. A common story about eBay that I mentioned also this morning is that eBay started by running everything in a single DLL. Now the cost of running in that mode means that you'll have to do a complete rewrite of your application along the way. Now in previous day, when eBay was probably the only player in the market that was, or the main player in the market that was running e-commerce, they could afford that period of time of doing that complete rewrite. But today, when there is more alternatives, if you need to go through that complete rewrite, there is a very good chance that you'll actually lose your market for competition, because today for users there are other alternatives, and alternatives can come faster, almost providing the same level of service than others. And therefore, working in that mode can have a huge risk on your business, because you can't really assume that you can do a complete rewrite along the way. So today you could still do that, but if we go a few years ahead, there is a very good chance that if your application is not designed for scalability in the first day, you're not going to be able to meet those demands. So what we try to do is take a lot of those patterns that people have been using to build their application, like partitioning, like putting the web codes in an asynchronous fashion so that the user wouldn't block on them, like using MapReduce and parallel processing to do fast queries on distributed data, like pushing the database out of the user transaction, and package all that in one solution. And obviously that gives you a lot of benefit, like the fact that you don't need to shop for all those different solutions and integrate them yourself, like the fact that it's all integrated and consistent with the same API, the same infrastructure, the same high availability model. You don't need to manage that yourself and deal with problems in each tier and find out which one fails just because it's separate products, etc. And those benefits really led me to the other item on the 7.0 release, which is performance. And so performance has always been a major theme in the GigaSpaces releases. A lot of people really come to GigaSpaces only when they look for very high performance. One of the things that we put as a challenge to the 7.0 release is a multi-core environment. Multi-core really gives us the power to run a lot of CPU in a single machine, but yet again, running an application that could leverage that number of cores is not that simple and requires a lot of low-level, almost like assembly concurrent programming skills. What we try to do is optimize the underlying middleware so that it will capture the value of those multi-core. And using the API abstraction that we have on top of that, we can enable the application to take advantage of those multi-core without going down the level of concurrent programming details that we have to go through. As you can see from the numbers, we got a fairly impressive improvement in 7.0. The main reason is because we were able to develop a lock-free data model, which I think is very unique. And as you can see, it's a 300% improvement that basically gives you the ability to run more effectively your application on this platform. So if you compare that to the previous release, you can see that as a fairly dramatic improvement on how we do local cache. Another thing that we wanted to deliver in the 7.0 release, which is basically a milestone in a more longer-term roadmap, is the new administration API. It might be the administration API is not necessarily the best name that we can call it, because the actual value that API really brings is much bigger than that. It really is, I think, the first product that provides a cluster administration API that opens the entire clustering for users to interact with. Usually clustering is a black box, is a black magic even to some people, and it's something that is dealt in a very rigid way in most of the platforms. In our case, we wanted really to expose it from several reasons. One is to give users the control to manage the scalability and the availability of their own business logic and code. And obviously, if you can look at clustering it in a more generic way, you could apply the same pattern that we did to our middleware to the entire application. The other thing is that you could write your own custom SLA. For example, you could say that your data center, you have a disaster recovery site and a primary site, and you want all the backups running on the primary site, on the disaster recovery site, and the primary is running on another data center, and you don't want them to share the same type of environment, and you want to automate all that type of behavior. So it will allow you to do things at that level as well. The other thing which is more obvious is that you could monitor more things with 7.0 than before, and there is from a user experience perspective, we did a revamp of the UI so that this type of measurements will show itself in a more user-friendly way. We also added metrics like system metrics of CPU utilization and memory utilization, all in one box, so you could easily correlate between event that happens on the operating system and event that happens within GigaSpaces, all in one consistent view. So that gets me to the next and final slide before I switch to a case, which is what's next. So obviously, the next thing that we're going to do is pretty much continue the same thing that we've done in 7.0 release, and even the previous release. And that means that we're going to continue to make distributed programming simple, and that's where the standard support comes in place. We want to make the programming with GigaSpaces as simple as possible and as standard as possible, and as long as we can support standards, we'll actually do that. The new EJB spec is very much similar to Spring, which solve a lot of the complexity that was previously introduced in previous J2, and therefore we can start and support that as well. We also realized that if we're running in a multi-tenant environment where more than one application is going to share our services, and it's not going to be like we're embedded within an application, we'll have to increase the level of security. So we're coming up with a very unique security model that I think covers the shared data infrastructure security. Multi-data center support is another thing that we're seeing, and that comes from different set of requirements. Basically, that means that we can run a cluster of cluster and have cluster running on multiple data centers, sharing information and synchronizing state between one another in a fairly simple way. I spoke about the admin API. One of the things that we'll be introducing more and more is built-in SLA. Things that algorithm that we'll find to be repetitive and useful for other users will just come out of the box, and you wouldn't need to interact with the admin API for those simple cases. And on the data layer, beyond performance, will enhance the querying capabilities of the product. I think that gets me to the point where we'll switch to a case. So case, the floor is yours.
Okay, just 1 second.
Thanks, Nadia. I'm waiting until I get control of the presentation so I can insert my own stuff.
Yeah, just 1 sec.
People pushing buttons all over the place.
Yeah, that's it.
There we are. Okay. So the next 20-ish minutes, I'll try to keep it below that, so in order to allow you more time for Q&A, which I always think is the most interesting bit of a presentation, not all the pre-cooked material. I'm going to present you what we're doing at Marktplaats, the biggest e-commerce site in the Netherlands, with GigaSpaces. If you have any questions, feel free to enter them in chat or now quickly scribble down my name and my email address before I move to the next slide. It's a bit of a longish agenda for 20 minutes, but I'm quite sure we will be able to run through it. I'll give you some background about who we are. Most of the people probably won't know Marktplaats, even though they know eBay, our parent company. I'll run you through some of the typical issues we have as a high-traffic e-commerce website and how we're trying to solve it with GigaSpaces. Okay, first a bit about me so you know who's talking. I'm doing this kind of work now for more than 2 decades, and at least what I certainly learned is not how not to build stuff, and I've seen some very bad and also very good examples. In Java, I'm probably one of the very early adopters, and also I'm one of the I count myself between one of the very early adopters of Genie and JavaSpaces, one of the technologies that GigaSpaces is bases on. And I hope that from the rest of my presentation, I also managed to make clear why Genie didn't cut it and GigaSpaces did cut it for us. Marktplaats is a pretty unique site as far as e-commerce goes worldwide, because I think we're the only classified site that is this large in percentages in the reach, relative reach in this country. Probably 90% of the people are using Marktplaats in the Netherlands every year. If you look at some of the figures on this slide, we're growing exponentially, even though we were already ingrained as the major e-commerce site for the last couple of years. We've been an eBay subsidiary for the last 4 years, and I think it's safe to assume that if you look at all the brands at the bottom of the slide, Marktplaats is the reason that all the other brands came aboard as well, because we sort of showed eBay the way how to go about doing e-commerce through classified sites. We have a huge reach, quite a number of new ads per day, 320,000 ads per day. That is a sustained average over a day of like 4 ads per second, but typically peak will be double that. And with 60 million visits and 18 page views per visit, you can do the math yourself. We serve an awesome amount of traffic. At the moment, we've organically grown around the initial Linux, Apache, MySQL, and PHP site. We've got a moderately sized development team, and one thing the team really is good at is doing stuff at high transactions, because our minor clusters do hundreds of transactions per second. But typically, we look about thousands of transactions per second. One of the drawbacks of having grown organically around the LAMP architecture is that we're now having to work with 500,000 lines of code in PHP, which is not an ideal language for managing 500,000 lines of code. The first product we set out to convert was something that we prototyped in the LAMP architecture, and that quickly became became clear that the LAMP architecture didn't get that much traffic is a product we call AdMarked. You see some screenshots of Marktplaats. I'll skip over them. But if you look at the top right screenshot, you see highlighted 3 listings in a search results listing. And these are what we call AdMarked ads. And these are ads that people can place pay-per-click. Typical placements on Marktplaats are either free or a fixed fee, so you can pay an extra 10 or 15 euros to come on top of the listing, etc. AdMarked caters more to B2C advertisers, so they have a pay-per-click model. And it's a typical set of customers we target at small and medium businesses, large companies, large web retailers, and intermediaries like media agencies and search engine marketing services. They're all using AdMarked. As we're showing them on every results page throughout the website, you can probably imagine, if you keep the numbers in your mind, that we are showing them quite often. And at the moment, it's still saying thousands of impressions per second. That's because the deck is a couple of months old. I think we now have crossed to 10,000 impressions per second. So we're serving 10,000 different AdMarked ads per second on various listing result pages. That immediately gets us to the core of our problem. If you have 10,000 transactions per second, because impressions for us are in transactions, we need to count impressions in order to have a click-through rate so we can optimize placement. We need to register impressions to make sure that people who are trying to defraud our system get caught. And if you are working on a regular old-fashioned database model, somehow you need to do tens of thousands of transactions per second. As I said, the current architecture is LAMP-based. Linux clusters, PHP, MySQL 5, we've got multiple clusters running behind Marktplaats. Netscalers are sitting in front of them. And we got a couple of 2 or 3 data centers. We're closing one, so I think we're back to 2 data centers around Amsterdam, where we're in the upper hundreds of servers for Marktplaats alone. And that's divided over web database clusters, but also specialized machines for batch mail. We're probably the largest mail sender in the Netherlands, so we need a separate cluster for that, etc. What we're looking at is especially the web and the database cluster, because that's a huge part of our setup, and that's also eating an awesome amount of our hosting costs in terms of especially electricity. Anyone in the hosting business will by now know that CapEx is negligible for servers. They're 1,000 euros per piece, and you can write them off over 3 years, but power bills are increasing and increasing, to the point where we really get interested in cutting down our power bills. One of the biggest issues, as I hinted at, is these 10,000 transactions per second. If you look at a typical MySQL cluster, you get a master, eventually a backup master, so you can do failover, and all the updates are sent to the master and then sent out to the slaves to replicate, and the slaves get all the reads. What is known, what we've seen, is that MySQL replication is fairly basic, so it just forwards all the queries, which means that all the slaves have to do all the query processing the master also has to do. And what we've seen multiple times is that at some point the slaves get saturated just doing updates, so there's no spare capacity for reads, which means that you can throw a gazillion slaves in a cluster, you still don't get any performance because all these slaves are busy updating a database. And it's a model that doesn't scale. You can work around it with federation and partitioning, but it's inherently broken. So to work around, I think Nati also hinted at it with some examples, and what we're doing is not too different at the moment from the industry. We use caching, we use SQLite to distribute data locally to the web servers. We got PHP acceleration tools, etc., etc. And over the last 2.5 years, the number of these patchwork solutions has grown to a degree that it's hardly manageable anymore. No one knows all the solutions. No one knows all the procedures and batch jobs that make sure that caching is valid or invalidated at time, pages are generated, etc. Basically, we're now operating something that most of the time, luckily, looks like it's in control, but when it spins out of control, we're seeing more and more that we have real problems to find out where stuff goes wrong and why we have downtime, which doesn't happen too often, but any downtime is too much. One interesting statistic is that we have a QA environment that emulates all the roles we got in production. For a handful of QA environments, we're already running 1,000 virtual machines. So, what we set out to do last year was to move to first development language that is faster, more performant, and more scalable in PHP. And also offered as a bit of well, stuff like training and certification, because at the moment, if you're hiring developers, it's a bit hard to adjust your levels, and that's one of the advantages for Java to us. What we also wanted to do is make it more manageable than the current system and keep it manageable at mostly the same level for 5 to 10 times the current level of traffic. So that means that it should be possible that we scale up to 5 to 10 times the current amount of traffic without having to hire 5 to 10 times the number of site operations people. And at the same time, we wanted to get rid of half to 2/3 of our web cluster, which is the web database machines. And we noticed quite early that if you keep the database in the loop, it's nigh impossible to do it. So we set out explicitly for a solution that could keep all the data in memory in a safe way. So we moved the database out of the loop, and after a bit of searching, we came down to a short list of only 2 vendors for several reasons. We had 2 vendors that were at a sufficiently high level to satisfy our needs, and we already also wanted to only evaluate 2 vendors so we could do a real in-depth evaluation. The interesting thing when people from these vendors started to talk about this is that Terracotta is talking a lot about technology, and GigaSpaces is talking a lot about solutions. There's a huge difference in the communication level there, where GigaSpaces is almost talking directly to our site operations people instead of developers. And Terracotta says, well, this is a huge, very funky distributed JVM, but you're basically on your own trying to write solutions on it. There are patterns, but it's a huge unknown world. And that's another point where GigaSpaces really had an advantage for us. Java concurrent programming is very hard, which meant that either we needed to train all our 40 developers to be cracks on Java concurrent programmers, or we need some help there. And GigaSpaces basically gives us all that help by giving patterns and having pre-cut, predefined libraries you can talk to implement these patterns. So basically, and that's what we saw in our first application, fairly quickly you crystallize out these patterns and you glue them together with a couple of tens of lines of framework code, and you're set up and you're free to go. So we chose GigaSpaces for AdMart. And that meant that pretty quick we were up and running with something that we could distribute and scale up. We tested that, of course, not production load official testing, but everything we tested during early development indicated that, yeah, we could indeed have all the work done in memory so that you never need to make more network calls than strictly necessary, and we can scale up our traffic just by scaling up the cluster and not by rewriting our code. Pretty soon after we had basic development complete, we did some formal testing. We had formal requirements to get them to 10K impressions per second on our production cluster. See the results here, and actually on what is the laptop I'm currently presenting on, with everything running locally, we went to 25K impressions per second, which is already quarter to this 5 to 10 times current future increase, which means that if you look at our production hardware, I think we're deploying on 6 of these machines. We'll be more easy. It'll be very easy to make these numbers, and that with maybe 100 lines of architecture framework code on our side, I think that's pretty impressive. Of course, not everything is a silver bullet, and neither is GigaSpaces. I'm sure they're the first to deny that. It's a great tool, but you need to know where you're going. One of the things I always tell to people if they want to look at distributed computing is to read a great Sun research paper by Jim Waldo and other people. Write down the tiny URL if you're inclined to reading science papers, or pass it on to someone who is. And it tells you exactly what you need to look at when working with distributed systems, cloud computing, or whatever. The basic gist of the story is you can never hide the network, which also means that GigaSpaces cannot completely hide the network. You need to think about how to partition, how to co-locate, etc., which also means that you need to retrain your developers to think that way. So even if you can get fairly quickly up to speed with a deployed GigaSpace application, if you're sticking to a basic servlet model, you'll have a much higher return on investment if you do some training with GigaSpaces and get up to speed. And what really helped us, especially in a performance sensitive environment, is that we had in the first or second sprint or development an automated performance test suite, which taught us that the first trivial attempt at solving some of the harder business logic was functionally correct but didn't scale. We subsequently solved that, and we now can take the performance test suite and run it against a deployment cluster whenever we want. So we're sure from sprint to sprint that we never break the contract we have, is that we can make a certain amount of impressions per second. Next steps from here is to finish off this product, which is functionally quite complete, but needs a lot of shaving to be able, especially on the user interface, to be able to roll out to all customers. At the same time, we are planning to rewrite everything of Marktplaats to Java. AdMark is a sort of pilot project because it was neat and self-contained, so we could do a full rewrite without being off the market for like 2 years. For Marktplaats, we're probably going to do it. We're going to do a full rewrite, but as you see the third bullet at the bottom, you don't want to do a full rewrite because basically your product management will be sitting on their hands for half a year, 2 years, whatever it takes. So we have some plan to first take the hardest performance, the highest performance hitters, and then gently move over code from PHP to GigaSpaces and having web service between there as the glue. And might be that a couple of simple static pages will stay in PHP indefinitely. One of the advantages of tackling this sort of rewrite with what we're doing with Scrum is that from sprint to sprint you can tell whether it's still worth the investment to port more from PHP to GigaSpaces, and when everyone agrees it doesn't, we keep the rest running in PHP. So that concludes my part of the presentation. Thanks for your attention. I'm hoping I'll be receiving a lot of questions in the next 20 minutes.
much, Case. So just before we're going to go to the questions, and people, please, we have a few, and we're looking to get from you many more. So just before that, Nati will give his final summary. Just 1 second.
Okay, so thank you very much. I'll switch to my slides in a second as soon as you can share. Okay, cool. I hope you can see my PowerPoint by now. So basically, just to sum up where we left, I think that you had a very good case study by Case on how a real e-commerce site could be implemented, and at the end, we got to the point where we can actually talk about what it did to the business, not just to the application itself, which eventually is to get more for what you paid for. In this slide, I'm trying to talk about that aspect and how do we translate technical benefit into value to the business. And basically, we're talking about several aspects. One of them is the fact that we can improve performance means that we can do more with the existing machines. The fact that we can make the application more reliable and avoid downtime means that we can save the downtime cost. And sometimes the downtime cost could be fairly big depending on the actual application and where it fits within the organization. In addition to that, one of the interesting aspects that we're seeing today, and probably the most cost-effective aspect of the things that we're doing, is if we look at the way the application is being provisioned, they pretty much provisioned by peak loads, which means that by definition, because on average we're not going to use all the peak load resources, our application is going to be under-provisioned. And if we can add dynamic scalability, that means that we can add machines only when we need to, and therefore we can use that spare machines for other things rather than constantly utilize them or take them into our application without releasing them. So that's a big factor that I think can save, and that together with the cloud computing, it can give you a lot of flexibility in how you deal with those things. Obviously, the fact that we remove moving parts and providing an end-to-end solution also means that you need less software components and less licenses. So that's another factor. And I mentioned the benchmark on the multi-core, and you can see that by the fact that you can leverage multi-core within a single application, that also means that you could use devs machines because those multi-core will provide you the power of multiple machines within one box. Simplicity is another factor, and I think Case mentioned that. It basically leads to the fact that you could reduce the time it takes you to develop the application, but it also gives you a more predictable estimates on the time to market of your application. You could have less surprises and less effort to develop the application, and eventually you could even get to the point where you could release your software earlier. Another part is the cloud migration, which basically enable us to outsource some of the, for example, testing on the cloud and production locally, which is a fairly common scenario, or even doing POC on the cloud and production locally enables you to at least spare some of the machines that you're currently running locally and outsource that piece outside of a data center. The last piece is really summarizing the main points, I think, from a GigaSpaces release perspective, and that comes in that order. The first thing is we're really trying to provide a single platform that enables you to run the entire application and reduce a lot of the complexity as a result of that. We talked already of the performance benefits. I'm not going to talk too much about that. The scalability and demand, I think we've touched that, but as I said, it's really the new model and how you run application in the data center. And one of the things that I didn't mention is that with GigaSpaces, you could really do that both on your local data center, but also on the cloud. We talked about reliability, which is what we refer to when we talk about always on. And the open architecture is one of the concluding items here, and I think is very important. our goal is really to provide all those capabilities in the ideal world without touching your code. So we're not here to provide an API or providing a locking mechanism. What we're trying to do is really to provide and inject a lot of those capabilities in a seamless way as possible and push a lot of the behavior into configuration and annotation rather than into code. Obviously, we're not there yet, and the market is not there yet, but that would be our ideal world. The way we reduce that is by integrating with other frameworks and putting a lot of effort to reduce that potential lock-in. I'll finish, and that would leave us with the open question with the fact that one of the things that we came up with in 7.0 is the cloud integration. And the basic idea, as you can see in this slide, is that you could log into our website, try out the product without even downloading it, benchmark it, and run it in a complete production-ready environment in basically one click in 2.5 minutes. That includes a load balancer, that includes database, that includes everything that you can think of. And the important thing is that you have full control of the machines, and it's a real hardware machine. It's not a simulated machines. So that, in my view, will also speed up and reduce another factor of reducing the learning curve, reduce another factor of the evaluation time it takes you to actually get into when you want to run or test the software. So I think with that, we can address and start and look at the questions. Alit?
So the first question is actually for you, Nati. The question is, what support do we have for .NET platform for ASP.NET and desktop applications in C#?
That's a very good question. We actually have support for .NET, a complete support for .NET. So GigaSpaces Zap is provided in Java and in .NET. There is a complete .NET edition. The .NET edition relies on the same infrastructure that the Coin Zap product relies on, but it provides a complete .NET API, so a user don't really need to know the underlying infrastructure. The benefit of that is that you can really get all the things that I mentioned, including the provisioning, the automation, the scaling, through that model. And therefore, I think it's pretty unique in the sense that it's not just providing you caching to .NET, it's really providing you an application container to .NET. And that's, I think, the main point in all this approach. So in general, what we're trying to get into is that whatever we have on our Java platform, we'll have the exact same thing on the .NET framework. We recently released the executor model in the .NET framework, and there's also in the 7.0 we came up with a new local cache. So the .NET is kept fairly much the same as the Java platform.
Okay, so another question is again for you, and then we'll start with the questions for Case. The question is, if someone is using an application that may not have scaling issues, only a few hundred users, but still want to use the middleware components that does not have that many moving parts, what do they do then?
Could you repeat that question again? Sorry.
Yeah. So if an application does not have scaling issue, only a matter of a few hundred users, but a developer still wants to use, excuse me, still wants to use the middleware component that does not have many moving parts, would there be a use case to use Zap?
Yeah, sure. I mean, first of all, even from a licensing perspective, we do provide something that we call standard edition that is coming with a fairly low cost. But generally speaking, the value that GigaSpaces provides is pretty wide. That includes scalability, high availability, and other things. It doesn't mean that you need to use all those capabilities in your product to take advantage of the product. For example, we did an integration with Mule, an OEM with Mule, which in their case, what they were looking for is mostly the high availability part of the product. And they were using the product primarily for that, and that's for the scalability, as you mentioned. We're seeing that in other cases where people are saying, well, we might need to hit scalability, but what we really need is the high availability or some other part of the product, and the fact that they know that we already provide the rest of the things makes them comfortable to know that somewhere down the road of the development, if they'll need it, they'll have it. They won't need to go through a complete reevaluation again. So that, I think, is one of the, I would say, common area in which we're seeing the use of GigaSpaces for other cases. Another case that we're seeing, which is more, I would say, the traditional way in which GigaSpaces has been using is for parallel processing. So people can use the product not for scaling, but at least for batching or for throwing away some of the heavy-duty tasks out of the context of their core application and leverage other part of the application in an asynchronous manner. So any component of the product can be used independently of the other in many ways, even though at the end they share the same underlying infrastructure.
Now we have a question for Case. The question is, you were talking about a transition and a gradual approach. How did you manage it, and what was the development experience and the learning curve with GigaSpaces software?
Okay, first I want to add a bit on the previous question, because one of the things I'm muted again.
Sorry.
One of the things we saw was
nice.
that we launched this AdMark product I think 2 years and 2 months ago, and we already started to realize that we needed a full rewrite after 1.5 years, which was way before we thought we would need a full rewrite. So starting with something like GigaSpaces, even if you don't need the scalability, it's there in case your product becomes a success. And now our team has to sit on their hands, our product management team has to sit on their hands while rewriting the whole thing. And that's typically not what product managers like to do. They want to have new features pushed out all the time. So that's really something we learned and will be taken into consideration. As for the transition, of course, we haven't started transitioning all our 40 developers in one go. So I'm leading a team which is, for some vague reason, internally called the Advanced Technology Team, which is a couple of more senior developers who also had some Java experience. So we were sort of leading the way with this project, which meant that we could concentrate with a small team on a overseeable product, how we needed to change our thinking, how we will be needing to train the larger developer community within our company to work. So, and of course, that's my little soapbox. We started to do this agile, which I can recommend to anyone, because you see week after week what's going well, what's not going well. You can adapt. So basically, in 1 or 2 months into the project, most of the people on the team were fairly well versed with GigaSpaces. We've seen what does work, what doesn't work. We've mastered to some degree the patterns we need to master. So we know if you do something like something we already implemented, we know how to do that. And basically, I feel pretty safe that whatever we learned now in a smaller team, we can roll out to the larger development team.
Nati, another one for you. Can Java and .NET interoperate to share data?
Yes. So the answer is that they can share data. The Java and .NET. What we did in the product is created what we refer to as a binary portable serialization. That basically means that any .NET object can be serialized in a way that can be deserialized in Java. And that's a layer that we added in both .NET and Java, and that's how we pretty much do that. Interestingly enough, we found that serialization, even if you're running only on .NET, is running much faster than the .NET serialization model. And it's pretty efficient protocol to do interoperability and still get the performance benefit.
Another one, how will you address the scaling on the web server?
What we provide is the following. First of all, we have a generic container model that can host different types of web containers. One container is the common one that comes with the product is based on Jetty, but in general it can support other containers. The integration with the load balancer is the first piece, and that includes an agent that listens to availability of web containers and update the load balancer when there is a new web container. So the load balancer is continuously being updated on the actual servers that are running in the system itself, and therefore we can remove a lot of the configuration and static load balancer configuration that most application is running with. The other thing on that regard is the ability to add more web containers as soon as the load grows, or remove them when the load goes down. And for that specific case, this is where the admin API that I mentioned earlier comes into place, and there is a policy that can listen to the traffic either from the load balancer or from a web container, and add more web containers or remove web containers through an API call. The session high availability enable us to store the user session in a shared data grid. Which basically means that regardless of the actual server that the HTTP request got into, and the session in which was stored in that server, if that request will be routed to another server, the actual session is not related to the actual server, the original server. It actually sits in that shared data grid, and therefore that new server will pull that session from that shared data grid and will enable to continue the same request from the exact point where it failed. So that's how we deal with the session high availability. Obviously, the fact that the web container can utilize any of the GigaSpaces data grid or remoting API means that the rest of the tiers in the application will also share the high availability.
One of the things we're looking at in terms of how open this all is that GigaSpace comes with a sample load balancer interface for the Apache load balancing module, and in the coming weeks we're going to integrate it with the Citrix NetScalers we're using. And so far the preliminary research I've done shows that this will be a relatively trivial task. The GigaSpace API is really nice, and Citrix NetScalers come with the SOAP interface you can use to control them. So the biggest hurdle for me is to actually get a NetScaler to develop against. That's really nice and easy.
Thanks. And there is another question for you, asking you if you're hiring Java developers with GigaSpaces experience. I thought it would be nice to actually mention. Yeah, exactly.
For vacancies never hurts. Yeah. We are looking for a couple of people who are really senior with Java and preferably GigaSpaces to lead up the retraining of our team during the coming conversion. So if you feel like working in Amsterdam, feel free to drop me your resume.
Okay.
Keith, I wanted to, if you can elaborate a bit more on the GigaSpaces versus the Terracotta experience, that will also, I think, be helpful.
In terms of hiring, or?
No. I'm talking about the Terracotta versus GigaSpaces that you referred to. I think that I saw a question there to elaborate about the experience that you had between the two.
Yeah, well, if you need my email, cedarbrood at ebay.com. I just saw a question pop up. If you feel like sending me emails.
Okay. There is also another question here. It says, Case, you mentioned that you would need to write some code parts of your system that use concurrency. What kind of processing would this typically be? And now that you've worked with GigaSpaces, do you still expect to need a lot of this kind of programming? Are there any simplification benefits in this area?
I think maybe that's something I didn't stress enough. As far as we added framework on top of GigaSpaces, it has been in the order of tens of lines of code. Most of the work actually is in deciding what functionality of GigaSpaces, what patterns to use in what case. So actually, we haven't written a whole lot of code around it, like glue code that doesn't execute core business logic. Most of the code is either very boilerplate, especially around executors, etc. That's MapReduce stuff. You need some couple of lines of boilerplate code, and then you're in your business processing already. Or some conventions, some coding conventions we adapted in the team. We laid down in a couple of simple interfaces. So actually, now if we're going for the second project, we don't need to do a lot of research, so we can save some time there. But if you look at real coding time, no, we haven't written a lot of code around concurrency. We defer to GigaSpaces for all of that. So I said, if the question is ending with, are there any simplification benefits in this area? Well, not having to deal with concurrency issues is a huge simplification benefit.
Okay, thank you very much.
Alit, there is another question here that I think, what if there are much update in the data? Is that scalable too? That I'd like to refer to. In general, the answer is that one of the things that I think Case mentioned also when I described the architecture in which we're addressing those issues is by pushing the database behind. If you look at the numbers that even Case mentioned, you could really realize that the number of updates, it wasn't just reads but also updates. You could get to that number of updates just because of that, because we can push all the interaction with the database behind. So we got to cases where we could actually get 100,000 transactions per second on a cluster of 16 nodes. In a common server, and I think Casey mentioned the number of 2,500 on your laptop, which is not
25,000 actually.
Oh, okay, 25,000 even. Okay, which is even more than what I thought. So these are the typical numbers that you would get with the GigaSpaces, and the only reason why is because we can push the data behind.
Thank you very much, Nati, and thank you, Case. I think this was our last question for this session. I'd like to thank Case really again and again for the time and the effort and for sharing with us your experiences. Thank you, Nati, for giving us your insight about GigaSpaces App 7.0, and thank you guys, attendees, for attending our webinar. I wish you a great day, and again asking you to please fill out our survey when you exit this webinar. The webinar has been recorded and will be posted on our website, and you will all get an email with a link to the recording. If anyone would like to get the slides specifically, you can contact us at webinar@gigaspaces.com. Thank you.
Thank you all.
Thanks.